Okay, let's talk about vector projections a little bit more. Last video, I just introduced you to the concept of what is a vector projection. This video we'll give you the formula for how to calculate the projection of one vector onto another, and then we'll do one example of how to use that formula, okay, and what the problem might look like on your homework or your quiz, okay. So this is for your notes. To find a vector projection, the formula is right here. The projection of a vector u onto vector v. This is the notation, okay? Projection of u onto v. The vector that's being projected is big. The vector that's being projected onto is small in the subscript. Okay, so that's what that means. It's a matter of doing a simple calculation, guys. You take the dot product of u and v, you divide by the magnitude of vector v squared, and then that's the scalar. That's just going to give you a number. You multiply that times vector v, and you'll get the projection of u onto v. And it makes sense that it's a scaled version of vector v, because if we're really projecting u onto v, let's draw what this is going to look like. Here's vector u, here's vector v, two different vectors. If I take u and project it down onto vector v, remember we look at that, we go 90 degrees to vector v. This part right here, that vector, this is the projection of u onto v. That's what this black vector is here, right? It's the part of u, it's like how much of u is in the direction of v. Now it makes sense that this black vector, it's just a scaled down version of vector v, which is why the formula makes sense that it's some constant multiplied by vector v, because you remember if you multiply a vector by something, it either shrinks or expands it, depending on whether you're multiplying it by a number that's greater than 1 to expand it, or by a number that's less than 1 in absolute value, that will shrink it. Okay. If you're curious to see the proof of this formula, that's on page 503 of your textbook, but I think I know you guys by now. When I give you a formula or a theorem, you trust me, you believe me, and you just want to know how to use it for your homework problems and stuff. So, but if you care about the proof, it's there. It actually uses the formula for the angle between two vectors, and a little bit of algebra and a little bit of SOHCAHTOA. Okay. So there is the formula for how to find this projection vector. Now, there's a lot of ways to find this. Okay, this formula is really nice if you have the component form of u and v, because then you can calculate the dot product really easily. But suppose you didn't have component form, but what you did know was maybe you knew this angle, and maybe you knew the magnitude of u. Well, then you could just do some SOHCAHTOA. Right? You could just use the cosine of theta adjacent over hypotenuse, because you have that right triangle there. Okay? Whenever you have a right triangle, even if it's made of vectors, you can use the Pythagorean theorem, your trig ratios, any of those rules that you've used on right triangles still apply, even though we're dealing with vectors. Okay? So just one more thing that I'll show you real quick is, what if u was going a different direction? Like, what if u was over here? Can we still project it onto v? Yes. Okay, so even though v is moving in this direction, we can still project onto it, but when we do that, what we're going to get is this vector right here. We're basically looking for the component of u that is parallel to v. Okay, so sometimes that might not overlap with v, it might be going in the opposite direction, but that would still be parallel with v, so that's what this projection vector would be defined as. Okay. And another question might be, well, what if u is longer than v? I'll draw a new picture for this. Suppose here's v, and here's u. Well, what if u is longer than v? What do we do then? Right? Same thing. We just draw this perpendicular dotted line to create the right triangle. We kind of extend v out past its endpoint. Okay. This vector here, we still drop this perpendicular from the tip of u onto v. This vector here, the projection of u onto v is going to be longer than v in some cases, if that component is longer than v. Okay, so sometimes it'll be in the opposite direction of v, sometimes it'll be longer than v, but what you know is it'll be parallel to v. It's the component of u that is parallel to v. Okay, okay, there's your formula. Hopefully you have an idea of what it's calculating for you. Let's use it on a problem. Okay, look at that. Mr. Troll had that pre-written. He planned this video. He's not just winging it as he goes. Hey, I'm getting better, okay? I'm improving, figuring out how to do this YouTube teacher stuff. Okay, Find the projection of u, and we have the component form of u, onto v, and we have the component form of v. Then write u as the sum of two vectors. This is the fun part, one of which is that projection of u onto v. Okay, so two parts. First, find the projection. We have a formula for that. Some of you guys have been asking me, Mr. Troll, is it okay if we use our notes on the quiz? That's a great question, and I am proud of you for asking that question, because that tells me that you are concerned with your integrity. What should I be allowed to use on the quiz, even though Mr. Troll's not here to enforce it? If I were you, I would take notes on these videos and maybe on the Canvas lessons. And the notes that I would like for you to use on the quiz are this stuff, the formulas. Okay, write down the formulas, because those are the most important parts. You can use that on the quiz. Stuff like worked out examples like this that I'm about to do right here, I would prefer that you don't use that on the quiz. Okay, because then the quiz will actually test that you understand how to use the formulas, and not just testing you how you can follow step by step a worked out example. Okay, so, but of course I'm not there to stop you, so that's that decision you're going to have to make for yourself. If you really care to learn this stuff, I would say leave this part out of your quiz notes. Okay, but you should still follow along, write this stuff down as I go. Okay, so we are finding the projection of u onto v has this formula, u dot v over magnitude of v squared times vector v. That's that formula we just wrote down, and I went ahead and graphed those two vectors just so we could see what we're calculating. Okay, remember, we're calculating the projection of u onto v, not v onto u. So from the tip of u, I draw this 90 degree, I drop a 90 degree perpendicular, and this part of v is that component of u that's parallel to v. So what I'm finding right here is I'm finding this vector that is the projection of u onto v. Okay, well, u dot v, we know the dot product. That's just the product of the x components, so that would be 3 times 5, 15, plus the product of the y components, 2 times negative 5, negative 10, over the magnitude of vector v. And so remember, that's the formula for the hypotenuse, right? The magnitude of vector v, I take a squared plus b squared, and I take the square root to get the magnitude of vector v. So that would be 5 squared, 25, plus negative 5 squared would be another 25, and then that magnitude gets squared. Okay, so that's nice. The square root and the square are going to cancel there, right? And I have to also multiply this whole thing times vector v, which is 5, negative 5. So this is going to simplify down to one number, and I just multiply that number by both components of v, and I've got my projection. Okay, so on top, 15 plus negative 10, 5, over my square root and my square undo each other, and then I've got 25 plus 25, so I've got 50 there, times this vector 5, negative 5, and then 5 over 50, that's going to simplify to 1/10, times 5, negative 5, and when I distribute the 1/10 in and multiply that times both my x and y components, we get 5 times 1/10, that's going to be 5/10, so I'm going to skip a step and just simplify that right now to 1 over 2. And then negative 5 times a tenth would be negative 5/10, which simplifies to negative 1/2. Okay, so this is the projection of u onto v. Does it look right with our picture? Let's see, I've got 1/2 and negative 1/2. So 1/2 in the x direction, down 1/2 in the y direction. 1/2 in the x direction, down 1/2 in the y direction. That looks pretty good. Okay, so that's what that vector is. Okay, are we done? No, we have a second job here. It says, then write u as the sum of two vectors. So one vector plus another vector equals u. One of these has to be the projection of v onto u. Okay, so I have to write u as the sum of this little black vector we found plus another vector. Do you see the other vector we have to add to this small vector plus what vector makes the green vector? It's this dotted line we've drawn. Okay. Projection vector plus dotted line vector will equal u, right? Because you take the tail of one vector, put it on the tip of the other vector. That's how you add two vectors together to get the final result of that vector u. So I've got this vector, projection vector, plus dotted vector equals u. I know the component form of vector u that was given to me. That's 3, 2. And now I know the component form of this vector, the projection vector. We just calculated that. 1/2, negative 1/2. And this vector here, that's my mystery vector that I don't know, that I want to know because I want to write 3, 2 as a sum of vector A plus vector B, right? I'll just call that vector A and vector B. Okay, so if A plus B equals vector u, then how am I going to find out vector B? Oh, subtract vector A from vector u, right? If 1/2 plus question mark equals 3, then 3 minus 1/2 will equal this question mark here, right? And if negative 1/2 plus question mark equals 2, then 2 minus negative 1/2 will give me this question mark. Okay, so I'll just show my work over here. Vector u is 3, 2 minus vector, the projection vector we found. Well, that's going to be, well, what's 3 minus 1/2? 3, that's 6 halves minus 1/2, that's going to be 5 halves. 2 is 4 halves plus 1/2, that's going to be 5 halves as well. Okay, so this 5/2, 5/2, or we could also write that as 2.5, 2.5 for those of you who really don't like improper fractions. Does that look like that? Okay, yeah, so this dotted vector looks like it goes over 2.5, up 2.5. Okay, so the final answer then, after we found the projection of u onto v, the second part says write u as the sum of two vectors, one of which is projection of v onto u. Here we can now write u as the sum of the two vectors, 1/2, negative 1/2, plus the other vector we just found, 5/2, 5/2. And you can double check your work, of course, by adding these vectors together, and you should get vector u, which was 3, 2. Okay. Okay, guys, I hope that helped. Wow, we're up to almost 13 minutes. Another long video. I hope these are helpful, guys. Please see me in my office hours or hit me on Remind if you got questions. Good luck with the practice problems and with the quiz. This series should have, I think 3 more videos. Okay, bye now.